All right, now we come to the hard one. We are going to write this with the order of integration dx, dz, dy. And the reason why this is hard is because if I'm starting with the variable x, I'm looking at which one is kind of the furthest up front for my region. Remember, the region is what's between this bowl and this canoe shape in the first octant. And what you might notice if you kind of try to visualize this, and what you'll notice even better if you look at it in Desmos, is that for the bottom of this graph, the canoe is going to be kind of closer to the YZ plane. It's going to be furthest back. But what that means is that's the part that's actually touching the region that I'm interested in. But once we get to the top, by the top, we're actually having the bowl shape is closest to the YZ plane. And that's the part that we're interested in as far as where these things intersect. So somewhere along the way, we go from the red region, or the red function being what we're interested in, to the blue function being what we're interested in. And what makes this especially tricky is it's not on like a straight line or something. It's on a kind of involved curve. So let's go ahead and see if we can find what that curve is going to be. And the important part is we need to find what that curve looks like in terms of in terms of y and z. So let me also kind of say what we're going to do. Usually we've waited to find what my functions are before I do this smushing thing. We're going to start by smushing just so that we have a better picture here. So since I'm starting with this x coordinate, I'm going to smush along the x-axis, and I'm going to get some picture with y and z coordinates. Let's do this in a couple steps. First of all, we have this graph up here. Let's start with the blue function, the bowl. If I were to smush that onto the x-axis, what would it look like? We'd have z equals 36 minus 4x squared minus 4y squared. You might notice that the widest part of this region is in the YZ plane where x equals 0. So it's widest when x equals 0. So we're just going to plug in 0 for x. And hey, there we go. We get z equals 36 minus 4y squared. So I'll have 36 up here. It's going to be important to note that this is going to intersect the y-axis when y equals 3. That was a slightly better parabola than the other one. That's okay. That was more like a line. Oh well. You can tell that this is very not to scale. That's 3, that's 36. Yeah, I don't care. If I were to look at what does the red graph look like if I smush along the z-axis, there's kind of just like a giant wash of red because the function is kind of perpendicular to the x-axis. So it's just going to kind of go forever and ever and ever. So that's not really going to be the most useful thing to look at. Perpendicular is the wrong word, but it's the same idea. If I were staring at this down the x-axis, I wouldn't see very much that's interesting. Okay. So let's go ahead and bring our attention to the important part, which is what does this intersection look like? So what does the intersection look like? I'm going to do this in purple. We're interested in where does 36 minus 4x squared minus 4y squared equal 5x squared. If I set those equal to each other, I'm going to get an answer in terms of x and y. So in order to find this intersection, I'm going to need to start by solving them both for x. Kind of, sort of. So we're going to have these functions z equals 36 minus 4x squared minus 4y squared. Solve that for x. I'll add 4x squared, subtract z from both sides. We'll get 4x squared equals 36 minus 4y squared minus z. Square root both sides, divide by 2. We'll end up getting x equals, if I only keep the positive value, we'll get 1/2 36 or square root of 36 minus 4y squared minus z. The other function is z equals 5x squared. Solve that for x. We'll get x equals square root of z over 5. And now, where do those equal? When I set these equal to each other, I'm going to get a solution that is in terms of now y and z instead of in terms of x and y. So, and we want it in terms of y and z so that we can draw this graph here. So we'll have 1/2 square root of 36 minus 4y squared minus z equals square root of z over 5. That's a z. Actually, it was a 5, but now it's a z. I can multiply both sides by 2 and square them. I'm going to do both of those in one step, just to make things a little quicker. I'll get 36 minus 4y squared minus z equals 4z over 5. I can go ahead and add 4/5 z to both sides. Maybe add z to both sides. That's what I want to do. We'll get 36 minus 4y squared equals 9/5 z. And then finally, I'm going to multiply both sides by 5/9. 5/9 times 36 is 20 minus 20/9 y squared equals z. And this is going to be my intersection. This is going to be a parabola, another downward facing parabola, but this time its z-intercept is 20. It's also going to intersect at 3. So here we'd have this shape like that. Okay. So if I'm looking at this and if I'm just looking at the region, now let's kind of fill in what goes where. Above this intersection line, the part of my region that I'm interested in, that's kind of bounding this region, is going to be the blue function, because that is closer to the YZ plane. Below that, though, now my function that I'm interested in, the one that's bounding my region, because it's closer to the YZ plane, is my red function. So I'm going to have two different integrals in two different places. And let's go ahead and we'll do those separately as a red and a blue. So let's also point out that this point right here is 3, because that's going to help us out later. For this first one, we start by saying, what's x going between? Well, we just said that in this bottom region, I'm bounding between this red graph, the canoe, and, of course, x is always greater than or equal to 0. So we'll have 0 is less than or equal to x is less than or equal to this thing solved for x, which we already did here. That's going to be square root of z over 5. We already did the smushing step, so that we can now see what's z going to be between. So what's z going between? Z is going between 0 in this red region. It's going between 0 and this intersection line, which in this case is 20 minus 20 over 9y squared. And then, we'll do one last smush. When I smush down on the z-axis, then I'm just going to have the spot that's between 0 and 3. That's what y is going between. So this is where we smush on z-axis. We get that y is between 0 and 3. Now let's go ahead and do the blue region. For the blue one, now again, x is always going to be greater than or equal to 0 for this shape because we're in the first octant. But now, the front function isn't going to be given by the red shape, it's going to be given by the blue shape. It's going to be given by, and we wrote that as 36 minus 4. Nope, that's the wrong thing. We solved that for z over here and got, nope, we solved it for x over here, and we got 1/2 square root of 36 minus 4y squared minus z. That's this function in terms, at least that's the front half of this function in terms of x. And then we smushed down. What is my z coordinate going between? Now it's going between these two different curves. It's going between the intersection, 20 minus 20/9 y squared is less than or equal to y is less than or equal to this top curve, which is 36 minus 4y squared. I'm just going to take a quick moment and say these were really important, and we've been using them. So I should have boxed them earlier when we were doing stuff. That's how we found this here and this here. So when you solve them for x, keep that. It wasn't just to help us find the intersection. It was also helping us get these amounts here. Just wanted to throw that out there. Okay, so we saw that y is between these, and then, nope, z is between those. I lied to you. And then last but not least, we smush down along the z-axis. And once again, we get the kind of same shape. This is going to smush down to the space between 0 and 3. So we get that y is between 0 and 3. Okay. And with that, that's all we need to answer this question. I ran out of room, so I'll give myself a little bit more room. So once again, I'm going to need to write my answer by adding two integrals together. Those integrals, the first one, let's do the red region first. I'm going to have 0 to 3 on the outside, 0 to 20 minus 20/9 y squared in the middle, and 0 to square root of z over 5 on the inside, 2 dx dz dy, plus, that's my red one, and then we'll have 0 to 3, the integral from 20 minus 20/9 y squared to 36 minus 4y squared, and then 0 to 1/2 square root of 36 minus 4y squared minus z, to dx dz dy. And that is it. We answered the problem. It was a bit of a nightmare, but gosh darn it, we got there in the end. So there you go. There's a little bit about how you can rewrite integrals by changing the order of integration with triple integrals, which can be really hard. So there you go.